And welcome to the latest edition of the CFES Brilliant Pathways webinar series. This edition is part of Computer Science Week. Zoom a scientist, and we have a very special guest today. We're excited about having on. We'll introduce in a second. I want to welcome all the schools from upstate New York, Atlanta, all around the country that are joining today. We really appreciate you, and we want to make sure you feel comfortable to ask any questions throughout. You can use the chat feature there. Anytime you want to ask a question, just put it in there. And I will introduce Cori Quirk, Program Manager at NASA Goddard Space Flight Center. It's our guest today. She's going to talk a little bit about her own pathway and also a lot of the jobs that are available that I had no idea existed. I'm sure you probably didn't either. There are all kinds of pathways that she'll share. And prior to that, I just want to introduce Chris Mazzella. He's our STEM coordinator, and he's going to talk just briefly a little bit about some of the things we have coming up.
Thanks, John. We are really promoting National Computer Science Week. There's so many careers, pathways for students, and one of the reasons we have Cori today is to be able to have her discuss her project and all of the integral pieces that play a huge role in putting this project together, which she's going to share. Just as a reminder, we are kicking off the week. It's technically Monday through Sunday of next week, but having the opportunity to get Cori to kick it off is really exciting. We do on Monday have our partner Champlain College. They're going to talk about the processes and the production of video games. And on Friday, Potsdam College is going to talk about careers in computer science and programming as well. And throughout the week, we are going to be promoting Hour of Code. So really excited that Cori from SAIC and a partner with NASA and Goddard Space Center is going to share her pathway and the great project that's happening right now with satellites. Welcome, Cori.
Hi, thank you. Hello, everyone. So as John and Chris mentioned, my name is Cori Quirk. I am a program manager at NASA in Greenbelt, Maryland. So it is right outside the nation's capital in Washington, D.C. And I'm going to talk to you a little bit today about how I got to where I am, the awesome program that I'm working on, and a little bit about how, if you're interested in science and technology, how you can work at NASA as well. I was always interested as a kid in middle and high school in science and math. Took a lot of science classes in high school, including all of the AP classes that my high school offered, and so was really excited just about the possibility of kind of being on the cutting edge and just doing really cool and fun stuff, right? I think, everybody on this call hopefully thinks that science is fun, and maybe that makes me a nerd, but, I hope that you're a nerd too. So, once I got to college, I honestly, when I started college, was a pre-med major. I thought, oh, definitely, I like science, I'm going to become a doctor. Turns out I didn't like my biology classes or my chemistry classes really as much, so that didn't really work out. But what I really loved were my physics classes in college. I went to a small liberal arts college in Pennsylvania. It's called Franklin and Marshall College. Awesome place, definitely check it out. But I really loved the physics classes, and what I really loved about that was being able to take the fundamentals of how the world works and mathematics and really see it in action, right? Physics and engineering is turning the building blocks of our world, right? The things that you're familiar with, like mass and gravity, and translating that into things like robotics and engines and motors and all sorts of cool stuff like that. And so that's what really kind of got me engaged in science and technology. And so once I graduated from Franklin and Marshall, I was looking for opportunities to do my postgraduate work figure out where I was going next. And I learned about an opportunity where several of the local colleges in Washington, D.C., including the university that I went to, the Catholic University of America, have consortium programs with NASA Goddard. And that is the case with a lot of NASA centers all over the United States, right? Not only do we have full-time engineers and scientists working at all of the different NASA centers, we also have students. And, getting your foot in the door as a student, whether it's at NASA or another government agency, anywhere that you can find that type of internship, really kind of gives you an idea of everything that there is to offer at that center. And so I bounced around a little bit when I started. When I started as a graduate student, I was actually doing research in galaxies. I was looking at science data, examining how galaxies were merging. That wasn't really my favorite thing, so I transitioned over into heliophysics, which is the study of the sun. And if you're not familiar, actually, the sun has a big impact on the Earth. There are solar storms and other types of radiation and particles that come from the sun and hit the Earth, and it can, it causes cool things like the aurora borealis on the poles, but it also impacts our power grid. And so scientists are looking at that. And so that's what I was doing when I was doing my graduate work. And when I graduated from Catholic University, I decided that I loved working at NASA, and so I was looking for jobs still at Goddard. And that's how I ended up in the position that I'm in now. And so what we're working on right now, whereas previously I was more on the science side, now I'm more on the engineering side, and we are building robots and sending them to space. So what I'm going to do here is show you a little video. Let me share my screen. Okay. So this is a video of, Chris, can you confirm that you can see this?
Yep, we can see it.
Okay, so this is the program that I'm working on. It is called OSAM-1. It's on orbit servicing, assembly, and manufacturing. And I'll tell you what's going on as we're going through this video, but really what we're doing is we are sending a robot into space that is going to refuel another satellite that's already up there. So just like your car runs out of gas, so do satellites, right? When we launch them from Earth, they only have a certain amount of gas and eventually they'll run out. Now, unlike where your car might run out of gas once a week, once every 2 weeks, a satellite often can go 20 or more years without running out of fuel. But often you hit that 20-year mark and everything else on the satellite is still working fine, right? It's still doing the science that we wanted it to do. It's still producing valuable data, but it's running out of fuel. And if the gas tank is empty, then it can't do all of the fun and valuable things that it was sent up to do. So we are developing robotic hardware to enable refueling of that satellite. So in this video, you can see here, this is what we are building down here in the bottom. So this is our spacecraft called OSAM-1 approaching the other spacecraft in the distance. Once we get there, we have one of our robotic arms is going to grab the tool that we're going to use to grab onto that other spacecraft. So that's what's happening here. We grab the tool. And all of these tools are mounted on the top here. Remember, everything has to be clamped in space or else it'll float away. So we get in position and now we're ready to go. Now we're going to approach. This is the spacecraft. It's been up there for over 20 years. It's running out of fuel and we are going to reach out and grab it. And this portion of the mission is fully autonomous. And what that means is there's no one, there's not a human being on the ground with a joystick or working on a computer telling OSAM what to do. Because there's a few minutes of delay if we send a signal from the ground between when it goes from our computer to the OSAM spacecraft, there's about 4 minutes delay. And so, as you can imagine, when you have two spacecraft moving towards each other like this, if you have a 4-minute delay between the command that you're sending and when it's receiving, you can have things banging into each other. And these are very expensive spacecraft, and we don't want that to happen. So we have trained our OSAM spacecraft to do this entirely on its own. Find the other satellite, reach out and grab it all on its own. So it'll reach out, it'll grab the ring on the bottom of the spacecraft. This ring was there to attach it to its original launch vehicle when it launched over 20 years ago. And we grab on and we pull it down and we put it on top of these berthing posts. And we're gonna clamp it in place. And those clamps are just there so that it's held in place and it won't move. And now we move on to the actual servicing, right? Because this spacecraft was not designed for this mission, it was never designed to be refueled, as most spacecraft are not. We have to get in there, right? We have to get into the fuel tank in order to put the fuel in. So we need to cut through this thermal blanketing here. That's what's happening right now. Takes a little while. Then there are safety caps that we need, or sorry, safety wires that we need to snip here that are holding these caps in place. And each of these operations uses a different tool. So between each of these, the robot arm is going back and getting a new tool. Now we're gonna go ahead and remove the caps, just like you do in your car, right? When you're refilling the gas in your car and you have to take the cap off, that's exactly what this robotic tool is doing. So now this is the bare refueling valve. And now is where we actually transfer the fuel. So the fuel that's being transferred is called hydrazine. And it's a little more caustic, I'd say, than the gas that you have in your car. So we need to be very, very careful and make sure that all of the connections are tight, that there's no hydrazine coming out, there's no leaks. We don't want it to float out and get on anything. So you can see here that the fuel was transferred, and we actually will then leave behind. This is our valve that we put in place, and we designed it such that we can leave it behind and it will seal off the system. And then we don't need to worry about screwing those caps back on or reinstalling the safety wires. And then we put it back into space. So that is what we are working on. We right now are finished designing the mission, but we haven't finished building it yet. Oh, sorry. I think the next video's playing. Sorry. Let me close out of that. So we have finished designing the mission, but we haven't finished building it. So I see actually a question that just popped up. How long did this take? So we actually started designing this mission over 5 years ago, from the very beginning concept. A lot of the engineers that work in my division worked on the Hubble servicing missions. So Hubble is a spacecraft that has produced, oh my goodness, so much valuable data to NASA. But when it was first launched, there was an issue with the images that were coming back, and they weren't clear. And so basically what we ended up doing was designing a servicing mission so that we sent, in that case, an astronaut to Hubble and put basically the equivalent of a pair of glasses over the lens, right? So we put another lens in place that corrected the vision of the spacecraft. And so that's where the idea of servicing came to life. And once we were finished all of the servicing missions on Hubble, then we decided, you know what? It's great to be able to send an astronaut, but what if we could send a robot, right? It's safer to send a robot. You can send them farther. You can do more complicated missions than you can with an astronaut. So in addition to having the option of doing a servicing mission with an astronaut, let's see if we can do it just with robots. And so that's what we're working on. So we've been working on OSAM for about 5 years, and now we're at the point where we're actually building it at Goddard. And it's slated to launch in December of 2024. So we have a few years of building left to go. And then once it launches in late 2024, then that whole refueling portion will take several months once we actually reach the satellite that we will be refueling. So that is a little bit of an overview of what I'm doing. And so I have not been keeping track of all of the questions that are popping up, but
I can help you out with some of the questions if that would help you. You're talking and trying to read at the same time, Cori.
Yeah, so if there's anything that I can answer now, that'd be great.
Well, so you did answer a couple of questions, and one of the questions I actually had for you, but it also came up from one of our students, is what are the challenges that you have found as a woman scientist or engineer? Because that was one of my questions. How can you promote young girls in STEM programs and that kind of stuff? But have you faced any challenges as a woman in this position?
Yeah, so that's a very good question. I would say that yes, starting when I was in school, in a lot of my physics classes, I was the only woman in the room, right? I was one of only a handful of women in the department that were pursuing a degree in physics. And that happens to me a lot now, although certainly not as frequently. Every year that goes by, it gets a little better. There are more women in the room. There's a little bit more diversity every single year. And what I would say is try not to be intimidated by that, right? I know that it can be hard. You feel like you kind of stick out like a sore thumb when you're the only woman in the room, the only person of color in the room, but make sure that your voice is heard. And if you have an answer to a question, raise your hand and answer it, right? Just because you feel like you aren't entirely fitting in doesn't mean that what you have to say isn't valuable. And so I think that that's something that I learned early on, is that as a woman, I might need to push a little harder to make sure that my voice is heard. And what I would say is one of the advantages that you all have is that you have more people that have gone through that are now in positions where we are the hiring managers, right? And so that certainly is something that I strongly take into consideration when I'm reviewing candidates for a role, especially for entry-level roles or intern roles, right? So a lot of corporations, including the one that I work for, have metrics that we need to meet. We have diversity goals to make sure that we are bringing in all different types of people. And I have seen enormous value in that. And I've seen a culture change at NASA in just the 15 years that I've been there, where when I started it was very much all men in the room, a room full of middle-aged men and me there, and at 22 ready to take on the world, right? But now I love the fact that on my program and all over NASA, I'm seeing a lot of women in senior leadership positions, and the same thing in my company. And so I would say that certainly make sure that you are valuing what you have to say and making your voice heard. Seek out mentors that can help you, right? People that have been through it. And I think that has been probably my biggest struggle, is finding people that have already paved the path that can help me follow along. And so, that's one of the reasons that I do events like this. And I know a lot of my female colleagues do as well, to make sure that we are providing those types of opportunities. So, don't ever hesitate to ask a question. Reach out to someone that you saw giving a presentation, or, someone that you work with or that your parents work with, right? And just say, hey, would you mind talking to me for 15 minutes about this issue that I'm having or how I might get to the next step? Because I am seeing the enormous value that is coming to my team the more diverse it becomes, and the more minds and people with different experiences and different life pathways are bringing just an enormous amount of value. And so, I, as a hiring manager now, want to make sure that I'm increasing that. And I know so many of my colleagues do as well. So, don't ever hesitate to reach out and ask someone, hey, how did you get to where you are now? Because, everyone loves to talk about themselves. So no one's going to turn.
You bring up a really good point. We, the company that you work with, SAIC, has been such a gracious partner to Brilliant Pathways. We actually have 50 people in your company willing to do virtual mentoring for our schools. So we will be rolling that out in the spring. So our students will have the opportunity, in particular the girls, but everybody will be able to have the opportunity to engage in a mentor in that capacity. So we're very grateful for that. We have a lot of questions coming, and I don't know if you want to keep answering questions and we can hold on those, or would you like to keep going with your presentation? There are one of the questions I think is important, because I think the capacity that you are managing in this project is unbelievable. How many people are working on this project? I think it would blow the kids away, the number of people who have to be, the teamwork and the integration and the agility and all these things that we promote, that you have to manage, is a little bit overwhelming.
Yeah, so actually I think that goes to one of the slides that I have in my presentation. So let me go ahead and share that. So we already went through that. Okay, so right, who's working on my program or at NASA in general? So OSAM 1 has about 500 people working on it right now. Depending on the day, depending on how many people I've hired this week versus other programs at Goddard, usually we're in the 1, 2, or 3 spot in terms of the biggest program at Goddard. So it takes a ton of incredibly talented people to build something like this, right? We are inventing this thing from scratch. This is the first time this has ever been done. And so everything that you saw in that video, everything from the robotic arms, the structure itself, every cable, every tool, everything, we're not going to Target and picking up an HDMI cable to connect those things, right? All of that is designed and built from scratch. So that takes a huge team of all different types of disciplines in order to get it done. We have the design engineers that are designing all of that hardware, right? Actually working in the computer programs to do the computer design and, the very detailed design of each one of those. For instance, one of the tools that we're working with is basically to cut the blanketing is like a pizza cutter. It's like a round tool. So to design that, they need to design every single piece of it. And then they need to test it. They need to run it through a bunch of tests, and then they need to build it. And so you then have a whole team of technicians that are responsible for doing the actual building. So, I employ technicians that build electrical equipment, mechanical equipment. They do things like welding. They're actually screwing the nuts and torquing the bolts. They are building all of our electrical, the computer chips and the wires and everything. They're doing all of the detailed soldering and all of that. And so those types of disciplines tend to come up through more of a technical trade background, or they've learned work on the job, right? On the job experience is incredibly important for those types of technicians. So as opposed to where some of the engineers have a background more like me, where they maybe went up through a bachelor's degree, did an advanced degree, the technicians tend to come up more through a trade school background, or really they started work right out of high school and just got into, doing that type of detailed technician work. And those people are incredibly valuable because you can only learn so much on a computer screen or in a classroom. But when the rubber really meets the road and you have to put something together, the person that knows, the best way and the most efficient way to do that, to make sure that it's going to work, that it's going to fit, are incredibly valuable. We have quality assurance inspections, right? So we are building all of this, but we need somebody to keep us in line and make sure that we're following all of the standards and that all of this is going to work and it's going to work safely. So everything that we build needs to be inspected. So I have a team of 12 quality assurance inspectors that work for me, and their whole job is inspecting that hardware. And there's all sorts of standards that the hardware needs to meet, and they'll go in every day. And if you built something, if you built a tool or you built a wire, that quality assurance inspector is going to inspect that wire and sign off and make sure that you're good to go. On my program, of course, we have roboticists, right? The big part of the program is those 2 robotic arms that are mounted on the spacecraft. And so we have people designing those arms, both the actual equipment itself and the software that runs it. And then we have the people that sit on the ground that actually, during the refueling portion of the mission, when we are controlling it from the ground, we have a robot operator sitting at Goddard typing commands into a computer that's actually controlling where that robot arm is going. Grab the pizza cutter tool, cut the blanketing, so all of that is happening from the ground. We have all sorts of other types of people as well, communications people, outreach people, management like myself, administration, so all sorts of different types of careers. And they're doing things like designing all of this hardware, building it, testing it. I mean, we test this hardware so much. What we say at NASA is test as you fly and fly as you test. So we want to test it on the ground to make sure it's going to work, right? Because unlike your car, once this thing gets up to space, we can't just send a mechanic if something goes wrong, right? We need to make sure before it gets off the ground, this is definitely going to work. And so we test. So for the next several years, we'll be testing this. So, that's the type of thing. And then I think over the next week, you'll be learning a lot about computer programming and software. We have a ton of software engineers working on my program because, all of this equipment, it needs software to run it. So, all of the communication between the robot arms and the satellite and our satellite with the other satellite and both of those satellites with the ground, right? All of that runs on software. So whether you want to be a hands-on person, really getting your hands dirty with the equipment, or you really love computers and doing software, or maybe you love people, right? That's why I do what I do, because even though I have a technical background, what I really love is the portion of my job that's dealing with the people, right? And that's most of what I do now, is managing all of the people so that they can do all of this awesome stuff.
That's awesome. Yeah, at CFES, I mean, certainly one of our essential skills, we really talk about teamwork. That is absolutely the epitome of teamwork. Taking a project this big over probably 9 to 10 years, getting it into space and having it function. And a lot of different, like you said, diverse backgrounds and a lot of different skill sets. One of the questions that came up is, how can students, say in the middle level, because we have a lot of students on our call today, 6th through 9th, 10th, 11th, 12th grade. How can they get inspired and how can they learn more about NASA or careers in NASA? Is there something that you would recommend that our young students do?
Yeah, so absolutely. So, one of the careers that I mentioned is communication and outreach, and NASA actually has some very talented people that are taking what we do and communicating it to the public. So I think the first step would be go and check out NASA's website. We have a great website. There's tons of information. You can find information about my program, all of the other programs going on at Goddard or at the NASA facilities around the world. And then, I would say another thing that you can do to kind of connect with what we're doing and potentially put you on a pathway to do what we do, once you're in the workforce, is a lot of participating in different school functions and clubs. Join the robotics club or the science club or whatever you have. Ask your parents for some sort of science kit for the holidays, or really, when I'm hiring young engineers, whether they're coming out of high school, they're coming out of college, whether it's for an internship or for a permanent position, a lot of what I'm seeing is they don't necessarily have a lot of work experience, but what they love to do is they have a Raspberry Pi, which is a little piece of electronics that they use to program a model train or to program a tiny robotic arm that I interviewed someone recently who is trying to program a robotic arm in his garage to make pizzas. Things like that actually end up being really useful. So any kind of opportunities that you have like that to kind of get your hands on something, or there are tons of online programs where you can learn to code, right? Get into computer programming. You can do so much, and all of that then kind of, it gives you experience that you can put on your resume, but it also teaches you how a scientist and an engineer thinks, right? And that's important because you are encountering problems, you're figuring out, how do I do research and solve this on my own? Whether it's just Googling what's going wrong with my code, why isn't it running properly, or working with other people, right? All of that fosters your opportunity to turn into someone that would be a valuable member of a scientific team.
Oh, wonderful. We have a comment. One of our technology teachers in our partner school, Mariah, they recently launched model rockets, and they discussed the first solid fuel rockets that were launched. Can you share with our students and our teachers, what are the type of rocket engines that will launch this robot into space, and how is it done?
Yeah, so that's a good question. We don't know which rocket we are going to go with yet. I can tell you that NASA right now is at a very exciting crossroads where, if you look 20, 30, 50 years ago, NASA really was its own entity, and we partnered a little bit with industry, but the space shuttle program was entirely within NASA. The rockets that were being designed were entirely within NASA. And so we now have this incredibly exciting opportunity to work with company partners like the SpaceX and Lockheed and Boeing, where we will not launch on a rocket that is being designed and built by NASA. We will buy one from industry because they have been making leaps and bounds in progress in terms of the rocket technology. So we haven't decided quite yet which one we are going to go with, but it will likely be from one of our industry partners.
Okay.
That's fascinating. I was just going to jump in, Chris, real quick. That with the private sector really kind of getting into space now, the opportunities for jobs are it's exploding. I got to say, just looking at the questions, we haven't had this type of engagement in a while. People are into this, right? So when they think, I want to work in this area, you just went through, you could go to trade school. I mean, there's literally any job that something you'd be interested in, you could get into this space by
Absolutely.
pursuing what you are good at and then kind of tailor it to that. So if you're just kind of channel, we have some kids in very rural areas and NASA is very exciting, but it seems like a bridge too far. And they're just thinking, how could I possibly ever get from here to there?
Mhm.
And it sounds like, and correct me if I'm wrong, if they were to major, it could be locally at Plattsburgh State or somewhere nearby in one of these majors that would then get them one of the jobs you listed, which were many. There's certainly a pathway to do it from not far from where they're at.
Right, absolutely. I did not grow up in a big city. I grew up in a very small town in Pennsylvania. So, you do not have to be from a big urban area or have that type of connection. I think, yeah, studying for sure, getting involved in clubs, and like you said, John, choosing one of the science fields as your major in college and applying for internships. Go to intern.nasa.gov, and we hire interns from every walk of life, from all over the place every summer. Most of our interns work during the summer, obviously because of the school schedule, but once you're in college, if you're local to a NASA center, or even a lot of our interns work remotely, you can apply to for work study during the year. So I would say definitely taking advantage of any type of internship opportunity, whether it's at NASA. I mean, go and apply for an internship at your local manufacturing plant.
Right.
I mean, I would love to see that on a resume, right? Just anything like that. Even I have hired people. I interviewed someone yesterday that is working currently as a mechanic in the military, right? That type of experience is incredibly valuable, right? Just because they aren't working on hardware that's going to go into space, the nuts and bolts of it are the same, right? So any type of experience like that, and then all you need is the foot in the door, and something like an internship or a connection can definitely get you that.
Yeah, thinking outside the box like that is fascinating. We had Southwest Airlines as one of our partners, and we have a lot of kids who want to become mechanics, and locally, and they think that means auto, which it does, tractor. There's all kinds of areas, but Southwest Airlines comes on and said, hey, you could be a mechanic for us at Southwest Airlines, extending that to everything that you just said. I mean, I have not, we haven't had a guest yet that in a field that has had literally the gamut of mechanic all the way up to someone with a master's in engineering. It's quite an impressive list. Chris, too, I noticed we've got a lot of questions.
You got some
Very
questions.
specific ones.
Well, there is one that I'm kind of curious too. Erica's asking, how did you come up with the name?
Oh, yeah, that's a good one. So until recently, actually, the program was called Restore L, because we were restoring a spacecraft, and the spacecraft we were restoring is called Landsat, so Restore L. But actually, we changed the name recently to reflect the fact that while this is NASA's first go at this, we hope that there will be many, many more. So that's the one, right? We are the first time that this is going on, but we hope that there will be many missions to come. And OSAM stands for On Orbit Servicing, Assembly, and Manufacturing. So the servicing portion is the portion that I showed you with the refueling. There's an assembly and manufacturing portion where once we're actually done the refueling, then we are going to take pieces of a spacecraft and use the robot arms and assemble them. So put them together in space. And then there's a manufacturing portion where we actually are going to have basically the equivalent of a 3D printer on board. And we are going to manufacture a piece of an antenna in space. And so really, OSAM 1, the on-orbit servicing, assembly, and manufacturing, is showing all of NASA's different capabilities and the future of what is possible, right? So right now, if we want to send a satellite onto orbit, we build it on the ground, and it's all put together. And a lot of times it's packaged up, and it might be folded in on itself for the launch configuration, but you launch it in one piece, And then once it gets there, it has to unfold. But imagine if instead of doing that, we launched a whole bunch of pieces and a robot, and the robot put it together, right? Now the sky is the space is the limit in terms of how big and how complicated this thing can be, right? Because you don't have to fit it on a launch vehicle. You don't have to make it simple enough that it can open itself up when it gets there, because it's just going to be assembled once it gets there. Or maybe you don't even need to launch the components. You launch the pieces that will turn into the components and you manufacture them in space, right? So this, we think, is really the future of how we're going to take that next step into bigger and better things.
You know, you mentioned 3D printing, and obviously many of our schools now are starting to have maker spaces. They're utilizing 3D printers and, you know, within their curriculum. And they're also, we had the question about the robotics or drone programs and things like that. What I really liked that you talked about was having the kids explore opportunities within their schools. I mean, maybe you know this, and some of our guests may not. I'm actually a former physics teacher, so I certainly love physics, and I love the idea that, you know, that is the basis of a lot of what you're doing. You know, within those programs and schools, are there things that schools can connect with NASA to help promote maker spaces, be able to access the ability to learn more about, say, drone programs or robotics programs? Is that where you go to the website, or where do you think?
Yeah, absolutely. So, you know, I was actually, as I was making this presentation, I was looking at the website a little bit, and we have a ton of opportunities. There's actually different suggestions in terms of projects that can be done with students, or, you know, for parents in their home. And NASA has a great Office of Education. We do a ton of STEM events, education events. We're very connected to a lot of our local schools. So, you know, I would say the website definitely is the first place to start. And then I will, I'll reach out to our education director and kind of get some more information and links, and I can pass that along.
That would be great. We'd love to share that out.
Cori, do you have just one quick question too? We have a few minutes left. You know, one of the things at CFES we talk a lot about are these essential skills, you know, known otherwise as soft skills often. You know, leader, and everything you're talking about, it's like pretty much applies to every one of them. It's teamwork, leadership, agility. A lot of our employers, and tell me if this is something you feel as well, you know, they'll say, you know, you go to school, you kind of get the technical piece, and you can learn how, they can teach them how to do the job, but they can't always teach them things like how to communicate with others, work on teams. Talk a little about the importance of that in your field.
Yeah, that is a fabulous question, and you really hit it on the head, right? And when a lot of what I do in my position is hiring. And so a lot of what I'm looking for, because like you said, I can teach someone how to solder a wire, or I can teach someone how to use a CAD program, a computer design program, or I can put them through a class, but I can't teach things like that. So I think that really is something that you want to foster now as you're going through school and getting into the career force. And, you know, those things are teamwork, right? Very infrequently will you get a job in which you do not have to interact with other human beings, right? I obviously have a huge team, and all of those people need to work together. And so I think, you know, joining programs in school, joining clubs, having to work on group projects, right? I can tell you, when I was in school, a group project was not my favorite thing. I would rather be in charge. I want to get it done the way that I want to get it done. But working on those types of group projects kind of teaches you how it is once you get to the workforce, right? You aren't the only voice in the room. And so I think learning how to work with other people, learning how to listen and communicate so that what you're saying gets your point across, and that you're actively listening to what the other person is saying, right? That is what we run into a lot in terms of issues with employees. You know, one person is saying one thing and the other person isn't really hearing them, right? Because you're just thinking about how you're going to respond. So I think communication is a soft skill that is hugely important, because you have to be able to communicate what's in your head to others, and you have to understand what they're saying, and that's how you work as a team. And I would say the last kind of soft skill that I really am always looking for is critical thinking, right? The ability to look at a problem, break it down into manageable parts, and come up with a plan and a path forward, right? That is huge in life, I can tell you, but also in any job that you're going to have, whether it's, you know, an engineering job like something that I'm building, or, you know, a communications job, or whatever it is, right? Learning how to think critically is huge. And the way that you learn that is by tackling problems, right? Whether that is software programming, or tinkering, or joining a club, or, you know, it really is the life equivalent of those dreaded word problems that they give you in math class, right? That everybody hates so much, right? That kind of is how life is. So, you know, really learning to think critically is hugely important.
You know, certainly that plays into, you know, one of our essential skills. We talk a lot about perseverance. You know, it's okay to fail.
Absolutely.
It is okay to tinker and build and have something fall apart, or try to write a piece of code and you're not successful and you have to go backwards and retry it. That's got to happen all the time with your team.
Oh my goodness, absolutely. I mean, let's just to talk about the tool that I keep mentioning, right? That rotary cutter, the pizza cutter tool. I mean, I don't know. At this point, I've lost count how many of those we've designed and scrapped and started from scratch, or changed huge pieces of it, right? I mean, that's what engineering is. You try something, it doesn't work. You try something else. You get more people in the room because obviously your brains aren't cutting it, right? You know, so absolutely. I mean, you can fail a million times. As long as time 1,000,001, you get it to work, then you've been successful.
Yeah, that's you know, that's STEM. You know, you take all the concepts, you integrate them together. You hope they work, and if they don't, you go back to the drawing board. And that's life as well.
Yeah.
That's a good place to probably come to a close. I mean, you think about how many us adults have all failed as countless times, but you keep persevering. I mean, this is, you know, the interaction on this has been amazing. We haven't had these many questions. There's a lot that we'll send you. There's quite a few that we haven't touched on. Anything else we didn't ask you, or Chris, any other questions maybe that we wanted to get in?
No, I think I'm good with questions. I mean, I hope that if there are students still on, I know usually 45-minute classes are probably are closed out now. I hope the kids listen and take advantage of this opportunity. And next week, you know, do an hour of code, get in and, you know, explore computer science and explore other options that you might want to be a machinist or something. But with technology, you're going to have some form of coding to do almost anything. And, you know, get your hands dirty on it.
Perfect. Yeah. Anything else, Cori? We really appreciate it. This is fantastic.
No, I think we covered everything that I have, and, you know, certainly, as I see there are 91 questions, you know, feel free to send them over, and I can shoot back some responses if you want to send them out. But I mean, I think a lot of the technical questions that are being asked are answered on the website. So, you know, certainly check out the website for my program and for NASA in general. And there is I mean, like I said, I was on there just when I was making this presentation, and there's a lot of cool stuff on there. So definitely check it out.
You know, one thing, Cori, just so you're aware, and all of if there are other teachers and students on here. This will be recorded, and there are a lot of classrooms watching this, which is great, but maybe if there are kids who are virtual who couldn't get in, we will have this recorded and we will share it out. So, your message will be seen by many, many students and faculty across the country, and we really appreciate it.
Awesome.
Yeah, thanks a lot, Cori. It was really enlightening. I think every time it's this particular, you think, oh, there's so many jobs in the field. Everybody thinks of 2 or 3, right? Doctor, nurse, and healthcare. I mean, what the amount of opportunities is just amazing. And thanks for sharing them. We'll continue to share them with all the students. So really
Right. And I think that, you just reminded me, but the last thing that I kind of wanted to say on that topic is that, that's a very good point, right? When I was in school, if you asked me to name the jobs that were available at NASA or just in general, right, a few would come to mind. So, just take the opportunities when they come up, right? I did not know that the job that I am doing existed when I was in school. And so many of my colleagues would say the same thing, right? So don't ever hesitate to jump and take an opportunity because, the more you see what's out there, you might decide that, oh, that thing I didn't even know existed, that's what I really want to do with my life.
Mm-hmm. Awesome. Perfect place to be.
Okay. Well, Cori, I hope we can get you back
Absolutely.
at some point. And obviously, with our partnership, we'll continue to engage students and your colleagues and give kids the opportunity to grow and maybe work at NASA someday.
Absolutely.
Awesome.
All right.
Thanks a lot.
Well, thank you.
Bye. Thanks.
Yeah.
Have a great day.
Thanks.